Hi, welcome to Lesson 6 of Energy Resources and Energy Transfer. Just going to spend the first minute or two recapping the way that heat can transfer, the things we've done in the last 3 lessons, and then we're going to look at some applications. How do we use this knowledge? So we started off by looking heat transfer by convection, so hot fluids rising, and we looked at some examples of that. That we have earthquakes because of convection currents within the mantle of the earth, hot magma rising. We looked at hot water systems. We look at heating of houses. We looked at sea breezes. We then looked at heat transfer by conduction. So when the particles vibrate and bump into each other, obviously this is how heat travels in solids, also gases and liquids as well, just not very good. We looked at why metals are good conductors of heat, because the particles are close together, and remember they have those free electrons that can also carry thermal energy. We talked about why gases are bad conductors of heat, also electricity, because the particles are far apart. And last lesson we looked at infrared radiation. So that invisible hot light that we can feel but we can't see, which also transfers. Remember, that's part of the electromagnetic spectrum. We discovered that black objects are good absorbers and shiny objects are good reflectors in infrared radiation, and less well known that hot black objects are good emitters of infrared radiation. They're good at losing their heat, and shiny objects aren't, and that was our recap of last lesson. Okay, so today we're just going to look forward now and look at how we use this, more particularly for insulation. This is a picture of Mrs. Porter a few years ago when we used to live in Norway. We were sledging. As you can see, she's got lots of layers on there. So insulation was quite important there. Okay, so let's have a look at some examples. In many countries, especially colder countries, in the roof space, which in English we call a loft, we have insulation there. So if you go up in the loft of many houses, there'll be thick layers of, this is like fiberglass. It's quite itchy. I'm surprised this guy in the picture doesn't have gloves on. This rock wool can get into your hands. And we do this obviously because it's very expensive to heat houses in cold countries, and the hot air rises. So if you don't insulate the ceiling, a lot of the heat will escape through the roof. Now, a good example of this, there are lots of pictures of this on the internet. You can see 2 houses here. Obviously the one on the left has got reasonably good loft insulation, so the snow doesn't melt, and the house on the right obviously doesn't have loft insulation, or not very good loft insulation, so the heat from the house is escaping through the roof. It's melted the snow. This is very expensive. One day you might have to pay your electricity bill in a European country, and electricity is very expensive. Okay, related to this is in many countries, and particularly in the UK, when you build a house, the walls are double walls. There are two layers of bricks, and there's a space in between. And that space it can be filled with air, but it's normally filled with an insulated material like fiberglass or a foam. And we call this cavity. In English, cavity means a space, cavity wall insulation. And this is for the same reason that we have loft insulation. It's very expensive to heat your house in many countries. You want to keep the heat inside the house. So this stuff is injected in the walls, the double wall that surrounds a house, again, to keep it warm and to insulate it. And finally, I'm going to look at a device, and this is related to your homework, the work you're going to do, that it has been specifically designed specially to not let heat enter or escape. This is a vacuum flask. Notice vacuum is spelled with 2 U's. It's the only word in the English language that has 2 U's together. Sometimes called a Thermos. A lot of these are built by a company called Thermos. So in the UK, you'll hear a lot of people saying, oh, it's a thermos flask, but the proper name is a vacuum flask. Now, how does this work? Well, first of all, it has an insulated lid. The lid is normally made of plastic or a material that's bad at conducting heat. And of course, that stops any hot air escaping by convection. So in general, the heat cannot escape the flask by convection. Okay, now, the flask, a little bit like the wall of a house, is double-sided. Okay, so the wall of the flask has 2 sides, and in between the wall is a vacuum. The air is sucked out of there. Now, of course, that means that heat cannot escape by conduction, because there are no particles there to vibrate together. So the heat can't escape by convection because of the lid. It can't escape by conduction because there is a space that has nothing in, a vacuum, hence it's called a vacuum flask. And now if you look inside a good vacuum flask, the inside is shiny, it's silvered. And as we know, shiny objects reflect infrared radiation. So the heat can't escape by infrared radiation either. You'll notice, now sometimes you can't see this because it has an extra wall as well, but also the vacuum part will also be silvered outside as well. Now sometimes that's covered up with another cover so you can't see that. We'll talk about that in a moment. So the heat can't enter or escape by infrared radiation either. So that means that hot liquids stay hot because literally the heat can't escape. It can't escape by convection, it can't escape by conduction, it can't escape by radiation. Now, that also means, of course, that heat can't enter either. So these vacuum flasks not only can keep hot drinks hot, but they can keep cold drinks cold. So if you've got cold Vimto in there, it will stay cold because the heat can't enter. Now, in reality, of course, it's not perfect, particularly the lid at the top. You know, there's no material that is a perfect insulator, so some heat will eventually escape through the lid, normally by conduction, but very slowly. You know, if it's a cheap vacuum flask, the vacuum won't be absolutely perfect, so some tiny might escape convection. So over the period of hours or sometimes days, if it's a good flask, the heat will escape. But it will certainly keep a hot drink hot for most of the day, and if it's a really good one, you know, maybe 2 days. So that means if you could make a perfect flask, so if it didn't have a lid, and if the vacuum was a perfect vacuum, and if it was perfectly shiny, the hot drink would stay hot forever because the heat wouldn't escape. Okay, so there's a worksheet to go with this. I'm just going to show you a little bit of the worksheet. So here it is, and what you need to do is to, this is a diagram, so you either to copy this or print it out and stick it in your book, and then you're going to have to label the diagram using these labels. So I'll give you an example. It said silvered outer, so obviously the silvered outer needs an arrow pointing to the outside of the flask. Yeah, the outside of the flask has a silver outer, and then of course we know that that stops heat entering by radiation, so these two will go together. Silvered outer stops heat entering by radiation. So be careful, this is quite a tricky task, this. Yeah, so either copy this diagram or print it out and stick it in your book, and then you're going to have to use these labels to label the diagram. Okay, well, as usual, please ask for help if you need it. Either message me or share my homework, or send me an email, or ask me during the workshops. Okay.